So we're going to talk about addition and subtraction with radicals, but before we get started on addition and subtraction with radicals, let's go backwards for a second and answer this question. And in fact, some of you probably, once you saw the paper, had it answered already. But what we're looking at is we're looking at like terms. And in fact, what we call this above expression is an example of combining like terms. And if we look closer at this, we see that we have a 9x squared minus 3x squared. And that gives us 6x squared. And we have 6y plus 14y. When we combine those, we end up with 20y. And the only other term left in our expression is the 2. And b plus 2. And that's an example of combining like terms. And for us, all that means is that we add or subtract the coefficients on each term, like we did 9 minus 3 to get 6x squared. So we added or subtracted the coefficients on each term with the same variable. Because after we got the x squareds, then we went to the y's, and then we went to our remaining term. And the thing is this same idea works when we have radicals in our expression. As we look at example A, negative 2 square root of 5 plus 6 square root of 3 plus 5 square root of 5 minus square root of 3. One little particularly interesting fact, conceivably, is that the number in front of this square root of 3, our last term in this expression, is a 1. And I can't write it in well enough. I'm going to try one more time. But the 1, it's just covering up. It's making it look like a plus, and I don't want to do that. So, but what we're going to do to combine like terms here is we're going to take negative 2 radical 5 plus 5 radical 5, and we add the coefficients. Negative 2 plus 5 is 3. And we leave the square root of 5 alone. Same thing with the 6 radical 3 minus radical 3. Again, I finally get the 1 in there. The number in front of square root of 3 is a 1 when nothing's written. It's out of sight and out of mind sometimes. So I want to stress that 6 minus 1 is 5 radical 3. That's all we can do to add those two together. Nothing else. We took the values that had the same radicals. On letter B, we need to use distributive property before we can combine any like terms. But when we use distributive property, 2 times the square root of 6. 2 times 4 is 8 times the square root of 11. And then we already have outside of that parentheses the square root of 11. And once again, I want to remind you that there's no number written in front of it. We can write a 1 if that's something that you forget. But after we write this, what I hope we see is that we have negative 8 radical 11 plus 1 radical 11. So the 2 square root of 6 isn't going to change. But we can combine these final two terms and we end up with minus 7 square root of 11. Lastly here on letter C, square root of 50, we need to simplify the square root of 50. We're going to make our factor tree, and I'm going to pick 5 times 10. You could have picked 25 times 2. It doesn't make any difference. 10 breaks down into 5 times 2. And in fact, what we're looking for is we're looking for 2 of the same value to take out 1. Well, 2 of the same value means that the square root of 50 can become 5 times the square root of 2. And then our next term is minus 4 square root of 2. And when we finish, 5 minus 4 is 1 square root of 2. No, you don't need to write the 1. 1 square root of 2 is fine if you just write the square root of 2. That is fine as well. So the takeaway, when we add or subtract radicals, we treat the radical like a variable, like the x squareds that we had at the very beginning, like the y's at the beginning. This means we only add or subtract the coefficients. We keep the radical. So let's look at a couple more of examples. Before we do, unlike addition and subtraction, when we multiply or divide radicals, we not only have to deal with the coefficients, which are the numbers out in front of them, but we also need to deal with their radicands. Radicands. And the radicand is the value underneath the square root. And I sometimes use that word, so I want to just at least have a definition of it somewhere where you can see it. There. Well, as we take a look at this, again, when we multiply, we need to deal with the coefficients. And the coefficients on this problem, A, are 6 and 2. Well, 6 times 2 is 12. Square root of 10 times square root of 3 is square root of 30. We dealt with both the number out in front and the number underneath. Now, it doesn't work out this time, but once we multiply, sometimes we're going to be able to simplify. And in this case, we can't. We do not have 2 of the same value to take out 1. So when we multiply, our answer is simply 12 times the square root of 30. When we look at letter B, same thing. Negative 2 times 10 is negative 20. 8 times 5 is 40. But we need to look at our square root to see if we can simplify. Well, 40 is 4 times 10, which is 2 times 2 for 4 and 2 times 5 for 10. And when we're looking at this, we're looking for 2 of the same to take out 1. And we end up with 2 times the square root of 10. Don't forget that we already had a value outside the radical of negative 20. And we're going to multiply those two together. Negative 20 times 2 is negative 40 radical 10. And this is our solution. Different only from problem A in the fact that we could simplify the 40, whereas we couldn't simplify the 30. When we look at division on letter C, what I recommend is that you do the division first and then simplify. it may be a little bit shorter. We're going to divide 12 by 4. And 12 divided by 4 is 3. Then we're going to divide the square root of 75 divided by 5, which is 15. And like problem A, the square root of 15 can't be broken down. It's 3 times 5. We don't have 2 of the same to take out 1. And what this eliminated here is it eliminated simplifying the square root of 75 first and then doing division. So one more time, I recommend divide first and then do any simplification that you need. As we flip our paper over to finish here, we're going to mix it up a little bit. So we've got adding, subtracting, multiplying, and dividing radicals in here. And I need to refer back to an old mathematics favorite, which is the order of operations. Sometimes your previous teachers have referred to it as PEMDAS. So order of operations, parentheses for the P, exponents for the E, multiply, divide, add, subtract. In this particular problem on letter A, where we're simplifying each expression, we need to multiply first. So we've got negative 5 times the square root of 10, but when we multiply, remember, multiply the coefficients. 4 times 6 is 24, and square root of 2 times square root of 5 is square root of 10. Well, we can finish this by combining our like terms. They both have the square root of 10 in them, so negative 5 plus 24 is 19. Square root of 10. As we look at letter B, same idea here. We need to do the multiplication first, which is in this parentheses here. We'll deal with the rest of it in a couple minutes. But the square root of 2 times the square root of 3 is the square root of 6. And then we have the square root of 13. Reminder again, there's no number written in front of the square root of 6. That means it's a 1. There's no number written in front of the square root of 13. That means it's a 1. Now, as we take a closer look at this, what we can identify are the like terms. 19 square root of 13 plus 1 square root of 13 is 20 square root of 13. Negative 11 radical 6 plus 1 square root of 6 is going to be 10 square root of 6. We cannot do anything else to this problem because we've got a square root of 13 and a square root of 6, and those are different radicands. So there is our simplified version. Letter C. That looks more complicated than it probably is, but what we need to do is we're going to do the multiplication first. So the top of that fraction there, we're going to multiply. We have 6 times 3 is 18. Square root of 14 times square root of 2 is square root of 28. We're going to divide by negative 9 radical 7. And we still have the square root of 8 and the square root of 2. But remember, in terms of our order of operations, multiply and divide before we add and subtract. So the next part is that we are going to divide. And divide here. 18 divided by negative 9 is negative 2. Square root of 28 divided by the square root of 7 is the square root of 4. And now we can go back and simplify. Well, what is the square root of 4? It's 2. This can be negative 2 times 2. Over here with the square root of 8, we're going to simplify it. And 8 is 4 times 2, which is 2 times 2 times 2. And once again, we need 2 of the same value to take out 1. So we're going to end up with 2 square root of 2. This last term here is the square root of 2. We can't do anything to it. But let's go back here to the left. Negative 2 times positive 2 is negative 4. We have one more thing to do. Hopefully you're reminding yourself that there's a 1 in front of there. Our like terms are here. Both of those terms have radicands of 2, square root of 2. You end up with negative 4 plus 1 square root of 2. 2 minus 1 is 1. And you do not have to write the 1. And to finish, square root of 24 plus 6 radical 3 minus the square root of 27. Simplify where you can on this particular problem. So we'll start off by simplifying the square root of 24. And making a factor tree. Square root of 24 is 4 times 6, which is 2 times 2, and 2 times 3. And we need 2 of the same value to take out 1. And we end up with 2 times the square root of 6. A single 2, a single 3. Our middle term can't be simplified anymore. It's done for us. 6 times the square root of 3. 27 can be simplified. It's 9 times 3, which is 3 times 3 times 3. And we need 2 of the same to take out 1. So we have 2 3s, we're going to take out 1, and then we have a single 3, still underneath the square root. And lastly, we look at this to determine our like terms. Well, we have 6 times the square root of 3 minus 3 square root of 3. The 2 square root of 6 is going to be there, but 6 minus 3 is 3 square root of 3.